So this was our final project. We did an EDA for chocolate bar rating. So now I would like to pass along to my teams to introduce themselves and go over the project.
Hi, I'm Sammy.
And I'm Anya.
I'm Jack.
And I'm Elijah.
And as Mr. Patel said, we did chocolate bar ratings. Our data was about the different flavors of the cacao, where it's produced, its ratings, etc. And our first step was inspection. The very first thing we did for inspection was looking at the first 5 rows of our data. And some notable columns are the reference column, the cacao percent, and the ingredients, which we're going to look into for cleaning. Our next chart is the null values chart, which you can see has all the null values. Ingredients is the only one with 87 null values. And it also shows the column names. On the right next to it is the statistical values of the quantitative data that we currently have. So this is without our cleaning of the data. So you have our ref value, which we're probably going to drop that, the review date, and the rating. It shows the minimum and maximum values, as well as the count and the statistical standard deviation, my bad. Yep, and the inspection summary is basically what I just told you. So on to cleaning the data.
Our next step is cleaning the data. So we need to actually turn this data into something we could use. So the first step in the cleaning process was to remove all the rows that contain null values. So just like a lumberjack, we chopped off all the rows that contain incomplete data, as those rows would do nothing but hinder our analysis. And since the amount of null values for the ingredients column was relatively low, we could just keep the column instead of dropping the whole entire thing. And right after that, we removed the ref column from our data set because it would serve absolutely no purpose in our analysis and would not help us answer our hypotheses. And our final step in cleaning the data was to convert all the values in the cocoa percent column into floats. The percentage sign in the data made it so all the values in the cocoa percent column were forced to be strings. And so in order to fix that, we gave the values a haircut and shaved off the percentages sign from it on each of those values. And after that, we were able to convert all the values in the cocoa percent column into real workable floats. In the end, we were able to remove useless columns and rows, and we were also able to enable the number summary for the cocoa percent column, as the data in it is now quantitative. And just like a school toilet after lunch, we were able to flush out all the bad elements, and now our data is ready for analysis.
Cool.
After we cleaned our data, we were ready to create some really cool visualizations to represent it, and we came up with 6 hypotheses that we would answer through our graphs. Our first hypothesis was what percentage of cocoa is most enjoyed. To answer this hypothesis, we have a pie chart that shows which cocoa percent was most highly rated, and from our analysis, we could conclude that ratings span from around 1 to 4, and out of these, the highest ratings went from around 3.3 to 4. And these were given to chocolates with a lower cocoa percent. And as you can see from the pie chart, the most enjoyed cocoa percent is 70.76, and it's ahead by 0.08% to the second lowest cocoa percentage.
And our second hypothesis was to figure out if there was any connection between the rating a chocolate bar got and the percentage of cocoa used to create that chocolate bar. And to figure this out, we created a line graph that plotted the ratings and the average percentage of cocoa used to create chocolate that had those ratings. And as you could see, there is a downwards linear trend that explains how, on average, as the rating for the chocolate increases, the average percentage of cocoa that makes up the chocolate bar decreases. And I would also like to mention how the highest average percent of cocoa makeup sat at a rating of 1.5, while the lowest average percent of cocoa makeup reached a full rating of 4.0. In essence, the more cuckoo for cocoa a chocolate bar is, on average, it'll receive a lower rating.
On to hypothesis 3. Does the data review affect the rating of a chocolate bar? So what we have graphed here is an average rating, basically all the ratings per year, average, you get the mean of it. And as we can sort of see, there's a bit of a sort of sporadic data set here. One thing I would like to note, of course, is the limited range of the data set. It starts at 3.05 and ends at 3.35. So you should take that into account when analyzing this data. So as we can see, the rating increases from the 3.06 in 2006 all the way up to 3.28 in 2022. This tells us that the correlation is positive as time goes on. The percentage change between the start and end dates is approximately 7%, meaning it raised the rating raised by 7% as time goes on. But as we can see, due to the limited range in the sort of sporadic data, the different changes, it wasn't a clear line or anything, we can sort of conclude that the review date is completely uncorrelated or mostly uncorrelated to the actual rating.
Our fourth hypothesis is what company consistently produces the best chocolate. So before we made this graph, we had to make a data frame of each rating in order to find the top 2 companies, and then we can make this graph. We then had to decide what we considered the best chocolate to be. And so we decided it was 3.25 ranking or above. And if you look at that, and then you go 3.25 to 4, there's one company on there that you can see is the most consistent, and that's the Soma company, or the dark blue color. So we concluded that Soma was the most consistent producer of the best chocolate.
Hypothesis 5 goes over, do companies have a favorite written ingredient combination or recipe, or is it just random? One thing I want to note is that the data set here uses similar colors for multiple different companies. So as we can see, one color can mean multiple different companies. If you were to actually analyze the data, you can see that on the bar graph, there's only one, there's about one ingredient combination per company that is used. A few have 1 or 2 extra recipes, but mostly just sticks to one primary thing. And this sort of tells us that they tend to be pretty set in place and are not random. Also, the most favored ingredient combination in this case is butter, sugar, and cream, which contains Soma as listed in the previous hypothesis. Next up is hypothesis 6, which goes over the correlation between the different features in the data. Specifically, the company location, review date, country of bean origin, cocoa percent, and finally rating. Normally, this graph would go from 1 to -1, showing the overall correlation, with -1 being negative correlation. But due to the lack of overall cohesiveness between the different areas in the graph, it only goes to about -0.1. Most of the data is very low, which overall tells us that there's a very weak correlation.
Yeah, and so to conclude from our chocolate bar ratings data set, we were able to answer 6 hypotheses, and we came to the conclusion that the most enjoyed cocoa percent is 70.76, and that the lower the cocoa percent, the higher the rating. And also the year of review and the associated rating is not very proportional, meaning that there's no set year in which ratings were mostly higher than the rest. We also found that the company Soma was the most consistent producer of the best chocolate, and that in general, companies didn't vary their ingredients much and mainly stuck to 1 to 2 combination of ingredients. And finally, we concluded that our data features are mostly independent since the values are close to 0 in the heat map and therefore aren't very correlated to each other. And yeah, that concludes our presentation. I'd like to thank my other team members and Mr. Patel for an amazing week. And yeah, thanks for listening.